Okay, grade 11s, we're moving right along. We're now going to look at predicted and experimental yield. When we run an experiment, we always have a prediction. That's how we start off our lab reports, and we also we have expectations for how a lab should perform. And so we can actually calculate, and we've been working on that through the stoichiometry in the first half of this unit. We can predict how much product we should be getting through our reaction. And we can look at the expected amount of product, and we're going to call that our predicted yield. Once we do the measurement and we actually obtain a value, we call that our experimental yield. So we did the reaction, and this is what we actually got. If you were to do an experiment and you predicted that you would get 10 grams of silver chloride when you reacted sodium chloride and silver nitrate, once you do the experiment, it is extremely rare for the predicted and the yield experiment to be the same. If you had the exact same results, your testing procedures would actually be called into question, because there is not a way that you can identically reproduce results. There's human error, there's glassware error, there's instrumentation error. There's too much to eliminate to be identical to the first way that you did your exam. So there's the factors that go into affecting experimental yield is that two chemicals can react to give different products. And we call those competing reactions. We've seen this a couple of times. We can have carbon and oxygen. We would think that we would get carbon dioxide. We can also get carbon monoxide. And sometimes when we're doing our calculation, we would always be calculating the carbon dioxide, but when we're actually doing the experiment, what we're recovering might actually be only carbon monoxide. Your reaction could be very slow, and so then you don't have 100% confidence that your reaction went to what we call completion. How you collect your sample and how you transfer your samples are never the same. The purity of your reactants and your products, and then when your reaction is very slow, did your reaction actually go to completion? Okay. Now, in a real ideal world, our percent yield should be as close to 100% as we can get. The closer to 100% we can get, the more confidence we can have in our experiment. And we can calculate percent yield by taking what we actually got and dividing it by our predicted yield. And we would multiply that by 100%. We've seen this. We've actually done this. In grade 8, When we mixed icing sugar and cornstarch together, we mixed them apart and then we did a bunch of different experiments to try and separate them. And then we calculated how much we got back. This is a percent yield. How much did we actually get back? We can also calculate our percent error for the experiment, which tells us how far we are from the theoretical yield. So the closer to zero your percentage is, the better the experiment, because you have less error. So percent error is going to be what you actually got back, your experimental yield, minus your calculated yield or your predicted yield. And we're going to divide it by what we thought we should get, what our theoretical value is. And we're going to multiply that by 100%. So for yield, we want to be as close to 100 as we can get. And for error, we want to be as close to 0 as we can get, which means that we were fairly accurate if we can do that. Let's look at some examples. Calculate the percent error and the percent yield for the following. We predicted the mass of a PPT, remember, stands for precipitate, as to be 6.20, and that the actual mass when we did it, we got back 7.12 grams. So we got more back than what we predicted. So percent yield is going to be equal to actual over predicted multiplied by 100. 7.12 grams divided by 6.20 grams multiplied by 100 should give us a value of 115%. Now, are we close to 100? Depends what you're talking about. 15%, if you're talking about kilograms and kilograms, then yes, 15% might be okay. But when you're talking milligrams and micrograms, 15% is a huge change in yield. Percent error is actual minus predicted divided by predicted multiplied by 100. So 7.12 minus 6.20 divided by 6.20 multiplied by 100, we're going to get a value of 14.8%. So when I worked at DMK Drilling Fluids and I worked in the lab, our target was actually between 95 and 105. And our percent error was anywhere from -1 to +1% error. So we had to be very accurate because we reported all of our numbers to the government, and the government expects you to be able to do your work properly. Again, it depends on what you're looking for. Are you putting seed into the ground and you're trying to calculate how much fertilizer you should put in? 115% might be acceptable. 85% might be acceptable. If you only put in 85% of your fertilizer, you might not have the same growth that you would expect, but if you put in 115% fertilizer, you might burn out your crop. So it really depends on what you're looking for in terms of percent error and percent yield. This one here, calculate the percent error and the percent yield for the following. I predicted that I should get 100 grams when I did my calculation through stoichiometry, And then I did the experiment. I actually reacted sodium chloride and silver nitrate together, and I got back 93.5 grams of silver chloride. So percent yield, again, is actual over predicted times 100. So I actually got 93.5 grams out of 100 grams. That one's easy, 93.5%. My percent error, actual minus predicted, over predicted, multiplied by 100. I am going to get 93.5 minus 100 divided by 100 multiplied by 100, and I should get a value of negative 6.50% error. Again, negative 6.5 is better than 14.8, but it's all in relation to what you're looking for. This negative indicates that you did not have your reaction go to completion. Your reaction was too slow. You didn't recover as much product as you thought you would. There was error in how you did the experiment. There was error in relation to your glassware. There's error in relation to your chemicals. There's human error in how you transferred or collected your sample. So all of these errors come into play. You're going to work now on page 20 and 21, and you're going to complete those questions.